Assalamualaikum and hi. Welcome to the next subtopic, which is the relationship between the polar and rectangular coordinates. At the end of this subtopic, you should be able to convert polar coordinates into rectangular coordinates, and conversely, you should also be able to convert rectangular coordinates into polar. Refer to the diagram at the slide there. You can see that we can represent a polar coordinate into a rectangular one and also rectangular into a polar coordinates. If you are given a polar coordinates r theta, if you want to convert it into xy, you can know that by this representation, x equals to r cos theta angle. Okay, and then for the y is r sin theta. Okay, this is the basics of trigo. And also, if you want to convert xy, okay, from rectangular xy into a polar, you can know that by this r equals to the square root of x squared plus y theta, and also tangent theta equals to y over x, or you can inverse tangent it, y over x. Okay, this is a fundamental equations that you need to know if you want to convert between polar to rectangular and vice versa. Okay, let's start first with how to convert a polar into a rectangular or Cartesian coordinate. Okay, you are given this example. Later we will do some exercise. Okay, this is point P. 6, the r is 6 and the angle is 2 pi over 3 in radian. It's a very good practice if you can visualize first. You can at least sketch which is 6 and 2 pi over 3, at least which quadrant will it be. Okay, based on this representation, it will be at quadrant 2, and as is given there, x equals to r cos theta. So you just take 6 cos 2 pi over 3 and you will get the value of negative 3. Whereas y is represented by r sin theta, then you just plug in 6 sin 2 pi over 3 and it will give you the value of 3 square root of 3. Therefore, this P in the rectangular coordinate system will be a negative 3 and also 3 square root of 3. And if you observe it, it is quite reasonable that the value of x will be negative and the value of y will be positive in the actual rectangular coordinate system or Cartesian. Okay, let's do one question first on how to convert the polar into a rectangular coordinate system first. Okay, question number 1. Okay, you are given a polar coordinate of 2 5 pi over 4 and you are required to change it into a rectangular coordinate. So x is r cos theta, so in this case is 2 cos 5 pi over 4. So it will be cos 5 pi over 4 times 2 it will be negative square root 2, whereas y r sin theta, you take it to sine 5 pi over 4 will also be negative square root 2. So the coordinate of this P in the form of rectangular coordinate will be a negative square root 2, negative square root 2. Okay, let's try to visualize where is the location of this one. Just briefly. Okay, 5 pi over 4 or 2 to 5, if I want to represent it in the form of polar, it will be 2 to 5. Okay. And let's say this is the point here, and the distance until the origin is 2, so r equals to 2. So in this is in the form of polar coordinate, and imagine if you convert it into a rectangular coordinate system, it will be negative square root 2 and negative square root 2. This totally makes sense, because it will be at the quadrant number 3 there. So the value of x is negative on the left, and the value of y is negative at the bottom part there. So remember one thing, polar to rectangular, x equals to r cos theta and y equals to r sin theta. Okay, let's go back to the case where we want to convert the rectangular coordinate into a polar. Okay, right now xy is negative 2 to square root 3. This in a form of rectangular again. We want to convert it into polar. Okay, the value of x is negative 2 and y equals to 2 square root 3. I know it's there, I just write it again. One thing that needs to be known, two things. The value of r is specifically the square root of x squared plus y squared. Okay, what will be the value here? X is negative 2, so negative 2 squared plus 2 square root 3 squared. You get the value of r equals to 4. Okay, whereas the angle theta is given by the tangent theta equals to y over x. So tangent theta right now I will get let me write it, 2 over square root 3 over negative 2. Okay, negative square root 3, and the angle will be the inverse of tangent of negative square root 3. Okay, shift tangent negative square root 3, you get negative 60. It's actually, if you put in the calculator, right? So negative 60 is negative pi over 3. Okay, this comes into a huge role here. The fundamentals of 3 go. Okay, negative pi over 3 will be here. Okay, negative pi over 3. Remember, this is a negative, so it will be moved clockwise. This will be negative pi over 3. However, if you want to represent it in the form of a positive angle, let's draw a line here, straight line here. This angle is equivalent. Okay, therefore, if you want it to be a positive angle here, anti-clockwise, it will be pi minus pi over 3, which is equivalent to 2 pi over 3. Okay, So to combine it in the form of polar coordinate, P will be 4 2 pi over 3. Okay, as we already at here, let me give you a recap of why the tangent is negative here. A quick one. Okay, trigo, the first quadrant, second, the third one, and the fourth one. You just need to remember A, S, T, C. A, all positive. This one only sine is positive, this one only tangent positive, and this one only cosine is positive. So because the tangent is negative at the quadrant 4, so it explains why tangent, the angle here is negative pi over 3. Okay. Alright, so to sum it, this will be 4 2 pi over 3. But if you want to represent it into a negative pi over 3, actually you can do that, but it will be resulting in the negative r there. So if you want to leave it as negative pi over 3, make sure the r also will be negative because it is on the opposite side there. But to be safe, you can maintain it as a positive angle there, so it will be much more direct. Okay, let's do one exercise here where you need to convert the rectangular coordinate into a polar one. Okay, let's do one example which we involve to convert the rectangular to polar. So given the coordinate in the rectangular coordinate system, x, y is 1, negative 1, and you want to convert it into the polar. Okay, so two things that need to remember is that the value of r is the square root of x squared plus y squared. For this case here, it's very easy here. Square root of 1 squared plus negative 1 squared, so it will be square root of 2. So we get the value of r already. In terms of the angle, this time, you take the tangent theta equals to y over x. So for this case, tangent theta equals to negative 1 over 1, negative 1. So the angle will be, tangent theta will be negative pi over 4. Okay. Actually, you already get the answer. Okay. The value of the polar coordinate p square root 2 negative pi over 4. Remember that this representation is that the angle is in the negative angle. Okay. So let's visualize a little bit. Okay, 1, negative 1. 1, negative 1. So this is the point. This is negative pi over 4. Okay, if you want to read this in the normal positive angle form, what you need to do, you can take the whole circle 2 pi and then you minus with pi over 4. So imagine if you want to convert that, okay, 2 pi minus pi over 4 is equivalent to 7 pi over 4. So in the form of polar coordinate, your p right now is square root 2. If you want to change it into a positive one, it will be square root 2 7 pi over 4. This one is 7 pi over 4. In the counterclockwise, but in the clockwise or negative angle, it will be negative pi over 4. This happens again because polar coordinate is not unique. Okay, until we see on the next lecture, please master yourself with the conversion from a polar coordinate to rectangular and also the rectangular to polar. Thank you.